All right, I'll go ahead and get started. First thing I want to do is point out the plan for the next few weeks, because believe it or not, we're getting close to being done for the whole semester. It seems like we just started, but we are not far from being done. This week, we've got another week with just 2 assignments that are due on Friday, 4.2 and 4.3. So like usual, this week I'll lecture over those. We'll have some class lab time, and Friday will be fully devoted to a class lab day. The week after that, next week, another set of 2. And then the week after that, well, there's exam 3. So we just finished up exam 2, it feels like. But exam 3 is coming up already. We still got 1 homework assignment that week, but also the exam 3. This is the last regular exam. We have a comprehensive final exam at the end of the semester, but this is the last regular exam. 3 regular exams, so that's the last one. Anyway, the week after that, then we got kind of a full week here. We got 3 of them due. And then the week after that is Thanksgiving. So Thanksgiving, we don't have classes on Wednesday, Thursday, and Friday, only Monday and Tuesday. So real short week. There's just 1 homework assignment due that week, Tuesday before our Thanksgiving break. When we come back from Thanksgiving break, we only have 1 more week of regular classes, and then we have final exam week. When we come back from Thanksgiving, this is the last week of regular classes. It's the first week of December. Just 2 more. The last 2 homework assignments are due at the end of that week. And then the week after that's final exam. We got the final exam. You can see it's grayed out right now, but that's for the final exam. You may be aware, but maybe you're not. During final exam week, everything is moved around. All your classes are kind of shuffled around so that they only meet 1 time and for a 2-hour block instead of a 1-hour block or 50 minutes. The reason for that is to give you 2 hours for your final exam. So the schedule that last week is going to be different than normal. Again, the idea is to give you 2 hours for your final exam. We don't actually meet as a class for our exams, including the final exam. So we will not meet at all during final exam week. You just go to the math lab when you're ready and you take the final exam. You can go at your convenience, just like with the regular exams. Anytime that week. You can take it early if you want, take it late if you want, however you want to do it. But we will not meet as a class at all during final exam week. So when we come back from Thanksgiving, we'll meet that last week of regular classes. And then we'll be done meeting as a whole. Anyway, that's the plan. Not that much left, really. We're almost done. Any questions about any of that stuff before I continue on? All right, well, I'm going to jump into section 4.2, which is really more of the same. Still dealing with polynomial functions. Still trying to get the graphs of them. Still using the end behavior, what's happening on the left and right sides, and trying to find the x-intercepts. But there's just a couple of new things to help us go a little further. And one is called the fundamental theorem of algebra. Oops. Every different type of math has something that they call their fundamental theorem. There's a fundamental theorem of algebra that I'm about to show you. There's a fundamental theorem of calculus that relates differential calculus to integral calculus. There's a fundamental theorem of statistics. And basically, it's the most important property in that area of mathematics. The word theorem just means property that can be proven. So this property of the fundamental theorem of algebra is the most important property in algebra. It says, if polynomial e of x has degree n, then there are at most n real zeros. So if you got a polynomial of degree 3, then that means there are 3 at most real zeros. There's not more than 3. There might be 3, there might be 2, there might be 1, there might be 0, but at most, whatever the degree is. Now there's different versions of this and some other versions. An alternate version of the fundamental theorem of algebra says if you got a polynomial degree n, then there are exactly n zeros if you count multiplicity and complex ones. But this version is just talking about real zeros. And the reason they're talking about real zeros only is because we're interested in the graphs. And real zeros correspond to x-intercepts. So zeros and x-intercepts are the same thing. So problem 1. Gives us a polynomial, x to the 4th minus x to the 3rd plus 1. But here's a polynomial, degrees highest power, which in this case is 4. So that means there are at most 4 real zeros. Which corresponds to x-intercepts. Again, ultimately, we're trying to figure out stuff about the graphs. So there are at most 4 zeros or x-intercepts. So f of x has a maximum of 4. Super easy. Just look at the degree. Then it asks something about, well, not the x-intercepts, also 4. Zeros and real zeros and x-intercepts are the same. And then it asks about turning points. So turning points, if you're talking about a graph, is, as it kind of implies, where the graph turns. So the idea is if there are at most 4 real zeros, 4 x-intercepts, that means at most you could hit the x-axis 4 times. So maybe something like this. Again, at the most, this graph would hit 4 times. So how many times would it turn? It'd turn 3 times. Because it's coming up here and then it turns down to hit it a second time. So there's 1 turn. Turns again here. So there's 2. Turns again here. There's 3. It's always 1 less. Because if it's got to hit the x-axis 4 times, then it has to turn 3 times. It has to change directions 3 times. Always 1 less. So that's kind of a consequence of the fundamental theorem of algebra. if the degree is in, then there are n minus 1 turning points. Yes.
Is negative x cube plus 1, does that mean anything?
Nope, it does not mean anything whatsoever in answering this problem here. All that matters is this degree right here. That could be really anything, and it wouldn't change my answer with these problems. At most 3 turning points, so it's always just one less. Number 2, just to do this one as well, it's exactly the same type of problem, just different problem here. It says f of x to the 11th. That's 3 x to the 5th. It's 2x minus so the degree I power is 11. So that means there are at most 11 real zeros. Fortunately, we don't have to find them. It'd be pretty difficult to find all 11 of them. But we know there's at most 11. We know there's about 11. And real zeros correspond to x-intercepts, so same answer there, 11. And then number of turning points, it's always one less, so 10. We don't actually have to find them or anything, just answer that. Number 3, now they actually start wanting us to figure out stuff about the graphs. Taking stuff we've learned in this section and in the previous section. One fifth x squared minus 4. So for this problem and a handful of them, they give you different graphs. We're going to choose the right one. It's always nice when it's multiple choice because you know the right answer is there somewhere. So you don't have to worry about generating the graph completely on your own. You just need to pick the right one. Anyway, what they say though is for the function f of x is 1/5 x squared minus 4. Use the leading term test and your knowledge about y-intercepts to match the function with one of the graphs below. So the leading term test, that's where we look at the leading term, we look at the degree, whether it's even or odd, the leading coefficient, whether it's positive or negative, and we can make a determination what's happening on the ends. Up on both sides, down on both sides, or up on one side, down on the other, depending on the situations. Like here, in this case, we'd say the degree is 2, which is even. What's important there is whether it's even or odd. Whenever it's even, it does the same thing on both sides, up on both sides or down on both sides. The leading coefficient is 1/5, so number part there. But what's important here is that it's positive. We're concerned about it being positive or negative. So it does the same thing on both sides, and because it's positive, it goes up on both sides. So at this point, we know the graph something like this. What's happening in the middle might be kind of complicated, but it definitely goes up on both sides. Because of this. That alone actually completely narrows it down for us. This one goes down on both sides. Can't be that one. This one goes up on one side, down on the other. And so does this one. So it can't be either one of those. It has to be B, because it's the only one that goes up on both sides. But just got to be complete because they say something about the y-intercept there. The y-intercept is when you plug in 0 for the x. Let's plug in 0 for the opposite letter. After y-intercept, plug in 0 for x. After x-intercept, plug in 0 for y. Y-intercept, plug in 0 for x. It's going to be -4. That means it's got to cross the y-axis, -4. So it's got to cross there. And of course, really, we know that this is quadratic, so it's a parabola. It's not super complicated in the middle like I did here to kind of generalize. But anyway, just from the end behavior, we knew it had to be this one, but just to kind of be complete, goes through the y-axis down there, -4. Definitely. A lot of these have lots of graphs to choose from. But this is the same type of problem, just a more complicated polynomial. X to the 5th. Minus x to the 4th. X squared plus 3. So same problem, figure out what's happening on the ends and think about the y-intercept. First of all, the end behavior, degree is 5, which is odd. It's an odd number. So that means it does opposite things on both sides. It's up on one side, down on the other. Leading coefficient is an understood 1, which is positive. So opposite things on both sides, positive, that means up to the right, down to the left. Up to the right, down to the left. What's in the middle might be kind of complicated in general, but down to the left and up to the right. That's still around this time, but got to have that into behavior. So that alone might narrow it down some. Down to the left, up to the right. So it can't be A. Going up on both sides. Can't be B. It's going up on one side, down the other, but it's backwards. Can't be C. It's backwards. One up to the left and down to the right. Maybe D. It's doing the right thing on the ends. It's going down to the left and up to the right. Can't be E, going down both sides, and can't be F, it's going up on both sides. So actually, we've really done enough to pick the right graph. It's got to be D. It's the only one that's going down to the left and up to the right. But again, just to be complete with the y-intercept, if I plug in 0, then all these terms here will be 0. I'll just be left at the constant 3. Got 0 to the 5th minus 0 to the 4th. What's 0 squared plus 3, which is 3. So putting that all together, it's got to go through The y-axis at 3. Down to the left, up to the right. Something like that. There we got a few of those. 6, though, same type of problem, really, but it's factored. When it's factored, it makes it easier to figure out the zeros or x-intercepts, but it does make it a little bit harder to figure out the end behavior because you can't quite as easily just glance at it and figure out the degree. When it's written like this, you look at it and say degree's 5, super easy. When it's factored, it's not so easy. Number 6, g of x is negative x minus 1 squared, x plus 4 squared. So first of all, to try to figure out the degree. Degree is high power of x, but the problem is it's factored. It's not multiplied out. We don't have individual terms being added or subtracted like the last one. But all you got to do is imagine the extra numbers being added and subtracted. Imagine they're not there. Like that minus 1. Just imagine that's not there. That would contribute an x squared. Likewise, that plus 4, that would also contribute an x squared. I got this x in the front, no extra number being added or subtracted there, so there's nothing to ignore. But if I do ignore that other stuff, I'd have a negative x from this. I'd have an x squared from this one if I ignore the minus 1. If I ignore the plus 4 there, I'd have another x squared. So I have an x times x squared times x squared again. You add the exponents. There's the 1 there. So 1 plus 2 plus 2 is 5. Got a leading coefficient there of negative 1. So the leading term would be negative 1 x to the 5th. So now we can conclude that the degree would be 5, which is odd. It's an odd number. So up on one side, down on the other. Leading coefficient is negative 1. In particular, it's negative. So when it's negative, that's down to the right, up to the left. So down to the right, up to the left. Again, at this point, might be kind of complicated what's happening in the middle. The end behavior is definitely up to the left, down to the right. So that alone narrows it down to these two. Because those two are going up to the left, down to the right. These two, this one's going up on both sides. That one's going up on one and down on the other, but it's backwards, not the right way. It's going to be one of these two. But I can figure out which one by the x-intercepts. I'll start on the right side and work my way to the other. Remember last week when we have factors like this, x plus 4, the negative 4 is a x-intercept over 0. It's opposite side. So negative 4 is an x-intercept. But it has an exponent of 2. So it doesn't cut through, it just touches, because that's an even degree. Doesn't cut through, it's just touches, or they prefer the word tangent. Comes up and touches at -4, but doesn't cross through. On my way to the left, I got a -1 there, so an x-intercept of +1. And it's also degree 2, which is even. So same thing there, it doesn't cut through, it's just tangents. Here's another x. And this one's kind of tricky though, because it doesn't look like x plus or minus a number, but we can think of it as x minus 0. So if you think of it as x minus 0, we've got another x-intercept of 0. Understood exponent of 1, so it does cut through to the top. It crosses. This negative up front, if I consider that separate from the x, it doesn't contribute itself to the x-intercepts. It's the x minus 1, and x plus 4. So if I put that all together, -4, 0, and +1. These are the places that the graph touches the x-axis. Maybe this tangent, maybe cuts through. If I go back to the end behavior, on the left side, I know it's got to go up. So it's going up this way. I'm coming from the other direction. It's got to come down and touch this one. It's got to come down and touch that x-intercept there, -4. But it doesn't cut through, it's just tangent. So it's got to just touch it and stay on that same side. Then it's got to curve around and it's got to hit this 0. That's another x-intercept. But it's going to cross through with this one. It's going to cross through. Then it's got to come up and hit this last one, 1. But it's just tangent. It doesn't cut through. It just is tangent. Comes up and just touches it. And then goes down to the right. Like we already knew from the movie. So roughly, it looks like this. So which one does that match up with? I think it's C here. You can see the x-intercept of -4, touches at -4, tangent, doesn't cut through, cuts through at the 0, comes up, hits the 1, tangent at the 1, then curves down. It's that one. Just to show you what this last one, it's a little off because it has -1, 0, and +4. It's just got signs backwards. If we were to read these off inappropriately, incorrectly, with a -1, +4, and 0, you get what's matching up with this graph here that is incorrect. Number 7. V of x negative parentheses x minus 1 to the 4th. Again, with the degree, imagine the extra numbers being added or subtracted aren't there when it's factored like this. So imagine that -1 isn't there. I would have a negative x to the 4th. Negative x to the 4th. And that's telling me my leading term. If I actually multiplied it all the way out, I'd have other terms of course, but they don't matter. It's negative x to the 4th. The degree is 4, which is even. Same thing on both sides, up on both sides or down on both sides. Leading coefficient's -1. Obviously negative. So down on both sides. Even with negative, down on both sides. Down on both sides. And what's in the middle in general can be really complicated. But down on both sides for sure. From what I looked at so far. So down on both sides. Can't be this one. It's going up on both sides. Maybe that one is going down. That one's going up on both sides. It can't be that one. I'm going down on both sides, so possibly that. So it's one of these two. Just from that. Next, to figure out the x-intercepts. When it's factored, it's just the opposite of the number sitting here. Positive 1 is the only one, but it has degree 4, which is even, so it's tangent. Doesn't cut through, it comes up and touches. So that's the only one. It's going to be going down both sides. It's going to be tangent there, so it comes up and touches. Doesn't cut through. So it's the one that looks like this. There's the two choices. They look very similar. You can see in D, we've got it over to the -1. You see it's over to the left a little bit. It looks like it flattens out a little bit because the 4th power, so it's not quite a parabola, just similar. But it's definitely to the left. Definitely negative. It's not that one. Notice the scale's really odd here. -100 to 100. -20 to +20, but it's definitely to the left, so it's definitely negative, so definitely not that one. Gotta be this one. Again, scale's really weird here. -20 to +20. -100 to +100, but it's to the right a little bit. We want something to the right. It's positive. It has to be that. Let's see. I'm sorry, D. Down both sides. No. The right one here, B. To the right a little bit, down both sides. Yeah. B. All right, number 8. They're just making it a little bit harder for us. Because in 8, they don't have it factored, and we have to figure out the x-intercepts ourselves, which means we have to factor it. And it's one of these harder ones to factor. It's got 4 terms. X, 10x to the 3rd minus 8x squared minus 90x plus 90. So first of all, for the indicator, just look at the leading term. In particular, the degree and leading coefficient. That'll tell us what's happening on the ends. The degree is 3. It's an odd number. That tells us opposite side, opposite turning on each end. Up on one side, down on the other. Leading coefficients. In particular, that's positive. So when it's positive, it's going to be positive to the right, negative to the left. So up to the right, down to the left. So at this point, what's happening in the middle, we don't know yet. Could be real complicated. But up to the right, down to the left for sure. To figure out better what's happening in the middle, I need to figure out the x-axis, where it hits the x-axis. That requires that I factor this. To factor this, though, is kind of tricky. We saw a couple of these last week. When there's 4 terms, we have to do what's called factoring by grouping. I've pointed out the last week also, but factoring by grouping does not, in general, always work. But it works sometimes, and it will work in all the problems they give you, because they set them up so that you can do that. Anyway, factoring by grouping says group the first 2 together. These things put parentheses around them, and the last 2. If there's a negative sign there, it needs to go into parentheses with it. It's applying to the 90. Still needs to apply to the 90 in parentheses. And then out of each pair, factor out common factor. So for this pair, both of those are even. So that means I can factor out a 2. And both of them have at least an x squared. That's got an x cubed, that's got an x squared. I can factor out an x squared. Like 2x squared. If I take 2, factor out a 2, I'm dividing by 2. 10 divided by 2 gives me 5. I'm left with 5. If I'm taking out an x squared, taking out 2 x's, I have 3, so I'm left with 1.
How'd you get 2x?
Well, I was just looking at what is divisible into both of these. So for the numbers, 2 divides into both of those, the 10 and the 8. And then for the x's, this one has 3 x's, the x cubed, that one has 2. So they both have at least 2. So that's where this came from, the 2. 2 the coefficients and the x to the 2 from the x to the powers.
What would you say about 15 and 12?
15 and 12, they're both divisible by 3. So you factor out 3. For this one, if I factor out a 2, divided by 2, that's a 4. If I take out x squared, then I've taken out all the x's. Just minus 4 there. Now this pair, both of those are divisible by 18. If I factor out or divide out an 18, I'm left with -5. Negative 90 divided by 18 is 5. -5. So on the x, divided by 18 here, I'm left with 4. Also, something to kind of think about when you're doing this is you need to end up with the same thing here and here. Otherwise, factoring by grouping doesn't work. So that can kind of help when you're trying to figure out what I need to factor out. Especially with 90 and 72, those are big numbers. But if you know you need to end up with the same thing as this, you'd say, well, I need to end up with 5. So what's 90 divided by 5? 18. Anyway, they're not quite the same for this particular case, though. They're just off by a sign. Positive 5x minus 4, that's negative 5x plus 4. But I can fix that by factoring out a negative. Negative 18, change the sign there, 5x plus 4. So now they're the same. Now I can factor out the whole thing, 5x minus 4. So if I take 5x up minus 4, 5x minus 4, factor that out, write it in the front. And in the new set of parentheses, right down what's left, 2x squared. For this one, I need to factor further because the ultimate goal is to get x plus or minus a number in all the factors. That's got an x squared. That one has an x, but it's got 5 in front of it. We need to fix that, but I'll save that for a second. This has got an x squared. It's a bigger concern, so I need to factor this first. But I noticed that both of these are even, so I can factor out of 2. Common factor of 2, x squared minus 1. Times 2. And now I've got x squared minus 9 or x squared minus 3 squared. Difference of 2 squares. So that kind of talked about last week. Gonna come up again here. When you got the difference of 2 squares, that factors into 2 factors. One that looks like this, no squares, and one that looks like this, no squares, but a plus sign. I've got 5x minus 4, 2x minus 3x plus 3. These two are in the right form. X plus or minus a number, so I can just read off the x-intercept of 0, 7. This one's got a small problem because it's got 5 in the front. Again, the factors need to be x all by itself, plus or minus a number. So I need to factor out a 5. So what I'm going to do, it's a little mathematical trick. I'm going to write this 4. That's 5 times 4 over 5. It seems kind of complicated and weird that I would do that, but I'm forcing a 5. I have just a 4. Put 5 over 5 with it. And the reason I'm doing that is because I'm going to factor out a 5. I want to factor out this 5, but I need a 5 in the other term to factor out with it. So now I can pick out that 5. Just turn this other stuff down. If I factor out that 5, then I'm left with x minus 4 over 5. Comes to x minus 3, x plus 3. And basically I'm done, but I'm going to do something just to kind of tidy this up. I've got a 5, just a coefficient, 2, that's also just a coefficient. If I move the 2 up to the front of 5, then I can actually multiply those. Make 10. So a lot of work, but I'm finally there. I can just read them off now. The zeros are positive 4 over 5, positive 3, and negative 3. The 10 out front, it doesn't have an x in it, so it doesn't contribute at all. It's just a coefficient, a number, doesn't contribute to the zeros. Zeros are values of x. Makes it. So now if I put this all together, I guess I should point out too, all of these only happen once. What's it one? So for each one of those, it's going to cut through. So I got 4 over 5. Which is a little less than 1, roughly there. I've got 3, then negative 3. So those are the x-intercepts. I know it needs to go down to the left, up to the right. So starting on the left side, comes from the bottom. I want to cut through. I come and hit this one, 4 or 5, cut through. Hit the 3 and also cut through. It look like that. So now which one is it? Possibly A. Looks like the numbers are a little off there. That's -5, so that's -1, 2, 3. That's a little off. Positive 1, 2, 3. That's a little off. So right through 0, and it's a little off. So they are a little off there. By the way, it's definitely not this one because that's going up on both sides. Definitely not this one either because that's going up on one side and down on the other, but the wrong way. So it's got to be this one, but just to verify. It's going down to the left, up to the right, so the end behavior is correct. -3. 4/5, so a little less than 1. That matches up. Then +3, that matches up as well, so it's got to be this one. They throw in another one of these piecewise defined functions. This time it's got 3 pieces though. And it's not completely related to what the rest of the section deals with, other than one of the pieces is a phone in the middle with one tone. But anyway, what this says is the graph should look like -x + 4, where the x's left than -3. So less than -3, that's to the left of -3. So to the left of -3 should look like this. And what does that look like? It's a line with the slope of -1, y-intercept of 4. So we need a line with a negative slope on the left side. Coming down. So a line coming down on the left side. All of them have that. But it does have the or equal to part with that. So it should have a solid dot with it. So it should be coming down with a solid dot. No one has an open dot or empty dot. So it's not that. That one's coming down to a solid dot. Maybe that one. That one's coming down to an open dot, not that. That one's coming down to a solid dot, so maybe that one. So narrowed it down to these two. Anyway, in the middle piece here, we've got that the function should be just 10 in between -3 and 1. So it should be a constant function, just means flat from -3 to 1. So -3 to 1, just a flat function. You can see all of these are. Neither end has the or equal to part, so it should have an open dot on both sides of the flat part. But it should have an open dot on both sides. That's the only one. That's the only one. So it has to be this one. But just to try to be complete, to the right, it looks like this function, where the x is bigger than 1. It should look like a cubic function, so it's going to curve up. See, they all do that. Also, it should have the solid dot because it has the or equal to part, so it should curve up with a solid dot. Those are open. Anyway, process of elimination, it's got to be this one. Anyway, there's a little bit more in this section. I'm out of time for today, so I'll pause here. That's all for today. Have a great rest of your day and see you all tomorrow.